Hey y'all, so again, I'm only going over in this video the circle questions, which are numbers 16 to 23. So if you need clarification on any of them, make sure you can always fast forward, pause, do what you got to do. So starting with 16, you're actually testing to see if LM is tangent. So we're testing to see, do we have that perpendicular, right? So remember, tangent is perpendicular to the radius. So here we had LM is 55, MN is 48, and LN is 73. So here, that means, again, Pythagorean theorem. So here your C is 73. We're testing, is 48 squared plus 55 squared, is that equal to C squared, which is 73 squared? So now simplifying, putting in the calculator, 48 squared plus 55 squared, you should get 5,329, which is equal to then 73 squared, which is also 5,329. So yes, that line is tangent because they are equal and Pythagorean theorem is true. Now, number 17, UV is tangent to circle T. So this with the radius TV is perpendicular. What is the radius of the circle? So we're looking for R, TV. TU is 30 and UV is 24. So again, here, notice how 30 is your C. So R squared plus 24 squared is equal to 30 squared. So now you're solving Pythagorean theorem here. R squared plus 24 squared, which is 576, is equal to 900. Now working backwards, subtract 576 from both sides. R squared is equal to 324. Now you can solve for R, guys, and take the square root, and your radius, you should get 18. So now for 18, you're looking for the measure of arc, WT. So when it's like the two letters like this, you're talking about a minor arc, not a major arc. So I don't want greater than 180. We're going to want less than. So WT is here. So we're solving for the measure of WT. Now we already have 100 degrees from the central, but we're missing this piece. But notice we have vertical angles. So if this is 55, now here I also have 55. So that means, now again, we do have the vertical because of the two diameters. So that's why here the measure of arc WT is 155 degrees. Now arc WTV. So now arc, just to erase to show you, arc WTV is now all around. So arc WTV. Now the way that I saw this is, well, again, I have my diameter. So I know that all of this here is 180. Then from the vertical, because of the other diagonal, this was 55. So I just added together 180 plus the 55. And that gets you this arc here of 235 degrees. So now 19. EF and GF are tangent. Both are tangent and they intersect at a common point here. So that means they are congruent to each other. So this is that concept, guys, when we're looking for the measure of angle, EGF, that's the question. That we not only have just any triangle, this is isosceles because the two tangents are congruent. So that means here, if we have isosceles, then the two base angles are congruent. So I can subtract 64 from 180, which is 116 degrees. Then divide that by 2 because the two base angles are congruent, they're equal to each other, and you get 58 degrees. So now number 20, if AB, the chord, is 13x minus 8, and CD, this chord, is 9x, find the length of arc AB. So we're looking for arc AB. Now, notice how these central angles are congruent to each other. So if they are congruent to each other, the chords are also congruent to each other. Everything, arcs, everything is congruent to each other. So now we just got to go through here and solve for x. So 13x minus 8 is equal to 9x. Solving for x, you should get x is equal to 2. Then plug back in and you should get 18. Now 21, you're looking for the value of z. Z here, this expression is at angle B. Now notice, B is on the circle. So this is now inscribed. But also notice how the endpoints for this inscribed angle for angle B are the endpoints of the diameter. So if the diameter is 180 degrees, then that means the inscribed angle, which is half, is a right angle, 90 degrees. So you can state that AZ, 8Z minus 6 is equal to 90. And now you're just solving your two-step. Add the 6, divide by 8. You should get Z is equal to 12. Now 24. Here you're focusing on the measure of arc, ADC. So ADC. So notice how here ADC is part of the endpoints here of our inscribed angle, which is 135 degrees. So if this angle here is creating the arc and it's inscribed, then we need to double it. So the measure of the arc, ADC, is 270 degrees. So again, so you guys can see here, this angle, the inscribed angle, 135 degrees. The endpoints, if you were to go around, create that arc, ADC. So that's why we're able to double it and get 270 degrees. Then here we're looking for the measure of angle ADE. So, oh, that's a typo. Sorry, I just realized that, and we'll make sure to have to fix that. So that should be angle DAE. So that is a typo. So DAE. DAE. This angle here, which is again inscribed on the circle. Notice how the endpoints, if you were to finish, create the 76 degrees. So again here, take that 76 and now half it. So half of that angle is 38 degrees. Or half of the arc, sorry about that, is 38 degrees. So now the last question. Again, it's an inscribed angle. It's on the circle. We're looking for the angle, but we're given the arc over here is 210 degrees. So to find the other arc, in order to find our angle, go ahead and subtract from 210. So 310, oh my goodness, there we go, 360 minus 210, right? So we've got 150 degrees. That is the measure of the arc. So again, because it's an inscribed angle, now we can half it. So that's why the measure of this angle here is 75 degrees.